Hello, Mr. Jackie here to talk to you about calculus and what calculus is all about. On to the slides. So for the first time ever in the 23-24 school year, we're going to offer AP Calculus and CCP Calculus at the exact same time. Calculus is calculus, so the same topics will be covered between the two things. The AP curriculum has a couple more topics in it compared to one semester of calculus through Southern State. So you'll learn a couple more things with the AP. AP transfers anywhere in the whole United States, because everybody knows what that is, versus a one semester of calculus through Southern State Community College. But there's been a request to I want some guaranteed credit. I'm afraid of the AP test. Well, if you do all the things that I ask you to do, you shouldn't be afraid of the AP test because it's just the stuff that we keep talking about over and over again. So what is calculus? Calculus has three topics to it. The first topic is limits. So the way I'm going to talk to you about limits real quick is a concept from biology, carrying capacity. So we have time here, and we have population, and we buy a house in the countryside of Ohio, and we build a pond next to it, and we introduce some fish into the pond, and the population of fish grows, but at some point it has to level off. Well, the place where it levels off is the carrying capacity, because we can't put infinitely many fish into our pond. So that carrying capacity is the limit. It's the limit that the pond will hold. So it's the limit of the function. It's the limit of this population function. So that's how I'm introducing limits to you, is through the idea of a biology concept and carrying capacity of a pond. The second topic and the third topic are totally connected to limits. Without limits, the next two topics will not exist in calculus. So limits are really important. They're the foundation of calculus. The next topic in calculus is derivatives. So derivatives are talking about the instantaneous rate of change. So instead of having change happen over a long period of time, we can talk about how something is changing at an instant in time, and we use derivatives to do that. So I'm going to go back to the pond example. So we have time, and we have our population of fish here, and we go zoop. So what we can do with a derivative and our tools of derivatives is we can calculate this point right there. And that point is a special point. It's because the population of fish is changing from increasing at an increasing rate to increasing at a decreasing rate. Okay, that's called the inflection point. Inflection point. So we can use methods, algebraic methods, to find an inflection point where it switches from being increasing at an increasing rate to increasing at a decreasing rate. That would be related to a derivative, because this is the instant point on the curve where the fish population is rising the fastest. So here the population is kind of rising a little bit, right? At the end it's kind of rising a little bit, but right there at that point it's rising at its fastest rate at that instant in time. So overall, we could talk about how the population goes from here to there for over a long period of time. So if we go from here to there, that would be how it's changing over the long period of time. But we want to talk in calculus about how is it changing at an instant in time. Then the next topic, which only works again because of limits, are integrals. So one of the basic applications of integrals is area and volume. So I can draw out a function, and I can shade in an area like so from a beginning point to an ending point, and I can find the area exactly of a curvy space. So I can have a curvy area, and I can find the area of it. I can take that curvy area and I can rotate it around an axis and create a volume, and I can find the volume of anything. basically. Any shape, any size, I can find the area or volume of it because of integrals. Integrals are basically adding up little tiny areas. So I can add up this area plus this area plus this area plus this area plus that area plus that area, and that's how you generate the area of a Kirby space. If you don't believe me that this is important and it works in all kinds of interesting situations, talk to Mr. Pullman. Mr. Pullman poured an epoxy pour for his kitchen dining room table, and I helped him out with that, with the math with it, and we used calculus methods to do that, to find an area and then translate that into a volume. And epoxy is very expensive, so the measurements and everything had to be really precise, and calculus saved the day for him. So I hope, again, that you take this class. It's a great class. I've taught it for many years, so you're getting an experienced teacher that will help you with this in any way that I can. People that take physics before calculus or take physics while they're taking calculus tend to understand some of the concepts in calculus, but that's not necessarily a requirement to be in calculus, but it certainly helps. So hopefully this video has been helpful.